Now, here's what we're going to do. Draw separate Venn diagrams with a universal set. So each one has to have a rectangle, correct? So we go 1, there's the second one, and then the third one I'll put up here, okay? Now guys, we're not unknown to doing these. These are easy for us, right? The first one has how many areas? 2 areas. The second one has, I'd argue, 4 areas. The last one has 8. I've often said that to you guys before, didn't I? It has 8 areas. So would you guys agree that so far it seems to be 2 for the first one, 4 for the second one, 8 for the third one. Can you predict the number for 4 sets? Yes.
16.
Most people say 16. The back of the book has 16. However, it's not the case. Let me show you what actually happens. Okay, let's go to my trusty diagram. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Now please remember that I don't have the rectangle here, do I? So if I had the rectangle attached to that as well, what would that mean? 14. Okay? Now guys, he was correct though. Danny saw a pattern. Danny saw 4, 2, 4, 8. And he goes, look, it's doubling every time. And Danny predicted the next one would be 16. That's a good idea. The book fell for that trap. I nearly fell for that trap. But here's what actually happens. Let me show you. What's the gap between 2 and 4?
2.
What's the gap between 4 and 8?
4.
What's the gap between... I'm going to go for 6 goes to 14. The next one will be 22. 5 sets will have 22. Everybody get that?
Yeah.
Now I can predict. It actually asked me to predict. Get this, right? Actually, this is such a tough question. It actually asked me, this is one of the only questions I ever had to look up in recent times, right? Does the pattern work if the universal set does not, so if we don't have the rectangle? Let's figure out if we don't have the rectangle, what would we have? So instead of 2, 4, 8, it's going to be 1, 3, 7. So it's 1, 3, 7, and 13. But guess this, look at the pattern. 2, 4, 6. Next one will be add on 8, which will get us 21. Okay, next thing. Would the universal set that contains 10 sets have less than or greater than 1,000 regions? Look, wait, chill out. Look at this. Ready? Okay, that's one. Would you agree that's 1 circle, 2 circles, 3 circles, 4 circles, 5 circles? You happy with that? We added on 8 last time, so what would be 6, 7, 8, 9, and 10? Let's find out. Okay, so for 6 circles it's going to be 32. That was add on 10. Then 74, followed by 18. Oddly enough, the person that actually designed this book got mixed up. He thought it was multiplied by 2 every time, which it isn't. Very easy mistake to make. Sometimes even the smartest of us overlook stuff and make mistakes. Right? Yes? Does that have to adjust the marking scheme once they realise it's wrong? Okay? So, there we go. Next thing, question 2. Draw a Venn diagram with a universal set P and Q. No worries. So what am I going to do here? That is P and Q. Okay, how many regions are there in the diagram?
4.
Yes, there is 4. Now, let's go for this. Alright. Everything in P is 14. Everything in Q is 18. What happens if I put an intersection in the middle? 14 minus x, and everybody happy enough with that? Would everybody agree that everything inside of Q is now 18 at the moment? How do I know it's 18? Add them together, and the answer is 18, isn't it? What about this part here? 14 minus x plus x? Still 14. Great. What is P and Q added together meant to be? So would you agree that the three regions added together should be 20? Let's add the three regions together. 14 minus x is region 1. This is region 2. This is region 3. And this must equal 24. So what does that mean? 32 take away x is 24. X must be 8. What do I do now, Tom? Chatty? So 18 take away x. X in the middle. 8. Queevin? Yes. Now, next one. 14 take away 8. 6. Now guys, let's find out what's going on here. Everything outside P is 22. So highlight P. And everything outside of P has to be 22. There's 10 here, so where's the other 12? There you go. Can you... Yes?
Can you just, like, take 18 and then 14 and 24, I guess?
A minus number?
Like, no, like 24 minus 18, and then...
Minus 14. Give you minus 8.
No, you do 24 minus 18 and then put it in. And then separate on 24 minus 14.
No, you have to put an x as the, if you don't know the intersection, you have to put x as the intersection and work it out. That won't work. No, this is the last exercise, isn't it? So we would have learned these methods in the first, second, and third exercise. So they're the established methods. Okay, guys, we're done, aren't we? Can you draw conclusions from parts 3 and 4 as to how many statements are needed to complete a diagram as described in part 1? Well, if there's 4, but that was 4 statements, wasn't it? So 4 statements for 4 parts. Yeah, I wouldn't worry about that, guys. Right? That's something that won't be asked. Okay. Now, what about this? Draw a Venn diagram for the universal sets and the sets L and T. LT obviously means laptop and tablet, correct? Okay, so laptop and tablets. So, let's do this, okay? I don't want to, I'll do this, I'll have it up here because I don't want to blank out the question. Un momento. I will make this white, and now it's gone. Okay, and then I will draw the diagrams here. Okay, laptop and tablet and a rectangle. Okay. Now, what do we have here, guys? 80% for laptops, which is just 80. 25% for tablets. And then tablets union. Laptops union tablets complement is 11. Okay, I think that means 11 on the outside, do you?
Yeah.
Because it means laptops or tablets, everything that isn't a laptop or tablet is 11%. So that's 11 on the outside. Everybody cool with that? Now what's the next thing we're going to do? X. Why do I need to put an X here? Were we given the intersection? No. So David, the best thing to do is put that X in the middle, okay? Then 80 take away X. And then what else? Can anybody in the class tell me what do these 3 regions have to add up to? I'd say all 4 regions have to add up to 100%. So 11 plus 80, take away x plus 25 minus x equals 100. Did I forget a section? I don't think so. Alright, and who said that? 106 was it? Or 116? 116, take away x equals 100, x will equal 16. Come back in here and what do I do? 80 take away 16. And then 16 in the middle. How many people did it this way? Oh dear. Okay. And that is 9. Alright, Heyman. Yeah, because 100% of people either don't have a laptop or a tablet. There's only really 4 types of people, really, isn't there? Like you either don't have either, You have you have a laptop only, you have a tablet only, or you have both. There's no other options, is there? So it has to add up to 100%. Why is it possible to complete the diagram in only 3 statements? Well, this statement gave us the outside region, and you only need 2 statements to find the inside region. So I suppose we can just explain it like this, that this statement here told us the outside, and we know there is a fourth statement though, isn't there? What's the fourth? The fourth statement is that everything must add up to 100%. So you need 4 statements for 4 regions. The fourth statement wasn't stated, but we know that all 4 regions have to add up to 100. Does that make sense? Okay. Why is it possible to complete the diagram? We just said that. If there were 75 people surveyed, how many had a laptop and a computer? 16% of 75 people. What is 16% of 75? Multiply 75 by 16% in your calculator. Somebody tell me the answer. 21 people. Yeah. 21 people, yeah? Great. Right, let's move on. Shh. Alright. This one here. Show this information on a Venn diagram. Easy marks here, guys. A, B, C. Okay. Danny, what will go into... Where do you usually start with these, Danny?
In the middle.
Alright. Any letters that are in all 3?
Or.
Or. Cross out or. Okay. Anything in A and B?
I.
I. So you knew how to do this.
Yeah.
Anything in B and C?
A.
M and A. Do you see the way I'm putting the dots beside them? That means they're individual. They're not the total amount of people there, they're just individual lists. Okay? M and A. Anything between A and C? E. So what's left over then? N. SP. Is the E gone already? Okay. The M and the A are gone, so just leaves over D. Alright. I expect you all to get that. List the elements of A union B. Everything in A and B. Come on, guys. Is it? Oh, Spider-Man, is it? Okay, grand. Spider-Man, Spider-Man, does whatever Spider-Man does. Okay, so, Spider-Man. I like it. That's A union B, okay? Now, what's B union C?
Direman.
What?
Direman.
Direman. How'd you spell that?
D-I-R-E.
D-I-R-E.
M-A-N.
Or Direman. Just like a super villain. Direman. Alright, great. Now, Direman, that's awesome. Alright, next thing. Shh. Lads, you looking? Everything in A union B, but also has to be in C. I would say that is all of this, Spider-Man. And then you just put in the N at the end as well. So would everybody agree it's all of Spider-Man? Okay, what about the next one then? What's A union B union C? B union C is Direman. Oh, sorry, Direman. But then you have the SP added in to make Spider-Man. So what does this mean? Is the order important? Which bracket you do first? It's not important because you ended up with the same answer. So this means that the union is associative. Associative means it doesn't matter which way you bracket it, you can still make it work. Okay. Okay. Number 9. Okay. This seems to be the distributive property. Can anybody in the class remind me give me an example of the distributive property using multiplication and addition? Yes, sir. So what do you want me to say? 20 is 4 times 5. So let's make it 4 times 3 plus 2. Would you agree 4 times 3 plus 2 is 20? What's the 2 ways you can do this question? Hands up. Yes, Adam. So you can multiply first and add. Sorry, I'm actually going to do this the long way if you don't mind, okay? Technically speaking, that is, look at the symbols, guys. That's 4 multiplied by 3 plus 2. Would you agree with that? How many symbols do you see there? I see a multiply and a plus. Now, if we multiply before we add, look what happens. Okay, don't want that. If we multiply before we add, it's going to be 4 multiplied by 3 plus, what's it? 4 multiplied by 2. Can you see that the multiplication happens, the multiplication happens twice, would you agree with that? And the addition only happens once. Do you see the way we multiplied twice and added once? That makes sense? So we got 4 times 3 is 12. 12 plus 8 is 20. Look at this up here, guys. See this P union? Actually, I'll do the same trick here. See the union in yellow? See the intersection in blue? Now look further down. Union happens twice and intersection only happens once. Do you see that? When comparing this one to this one here. Do you see that? It's the same thing as the multiplication and the addition. Now, because you get the same answer, you could have added first, couldn't you? And you could have just done 4 multiplied by 5 to get 20. What we're saying here, Danny, is that you can multiply before you add. Yeah. And that means that multiplication is distributive over addition. Correct? If we do this question, and if part 3 happens to be the same answer as part 5, what does that mean? Union is distributive over intersection. Exactly. That's what we're looking to do here, people. Okay? That's what we're looking to do. Let's find out. You ready? Okay. Now, 1 second, guys. I need to get these numbers here. Oh, there's 3 of them. That's all the fun. 1, 2. Would somebody be nice and just give me the completed Venn diagram so I don't have to struggle through this? Okay, so what's P, Q, and R, is it? Yeah. Okay, what's dead center? O. What's here? P and Q? A. What's here? U and N? Yeah, P and R? R. Here? What? PL. And here? Y and G. Okay, lads. Shh. D. Where's the D? Here. Anything else? Should no. Okay. Shh. Okay. Now, first things first. List the elements of Q intersection R. What is Q intersection R? O, U, and N. So O, U, and N. Okay, what is hence find P union Q intersection R? I like to do this the highlighter way because this is what my eyesight does in a test, alright? So Q intersection R is this part here. Do not use green. This part here. Everybody alright with that? That's Q intersection R. Union P. So where's union P? Also includes P. Is everybody happy with this region here? Yeah. What is the answer for that region there? P, L, R, A, O, U, and N. Okay, so I'll have to do that again. Just give me a sec. Anybody else remember that there? It's P, L, R. Was R in there? Yeah. O, A, U, and N. Okay. Nextly, it wants me to list the units of P union Q. What is P union Q? P union Q, lads? Okay, so P, L, R, O, A, U, N, G, and Y. Everybody cool with that? And what's P union R? Now, what's P union R? No, P union R. P, L, R, O, U, N, D. Will they have the same answer? Intersection means what, guys? What do they have in common? I'd say that. P, P, L, L, R, R, O, O, U, U, N, N. That's it. I don't know, that one didn't have an A. Second one doesn't have an A. So it's P, L, R, O, U, N. Is that the same answer as the last one? We need an A. Oh, sorry, the A is in it as well because it's P, so my fault. So there is an A in here as well. So it's P, L, O, O, U, R, and A. Is it the same answer as the last one?
Yeah.
Yes, it is. Lads, if you guys are doing this visually like I do, I'm very visual with my learning, here's what I would have done. I would have done P union Q first. P union Q is the yellow section. Okay, and where is P union R? P union R is this section here. Intersection is the green parts, the parts they have in common. What are the parts they have in common? P, L, R, O, A, U, and N. Everybody right?
Yeah.
12, hopefully. Hooray. Now, 12. Draw two Venn diagrams, each with sets X, Y, and Z. Shade Y union Z on the first, and hence shade X intersection Y intersection U on the second. Oh wait, I'm leaving out one here. How many Venn diagrams are going to need here?
3.
3, is it? Okay, so I'm going to do my copy and paste trick because I'm lazy. So, 1. And they're always called X, Y, and Z, aren't they? Okay, brilliant. Shh. What's the clone function again? Control D. Okay. Yeah, got it. Alright. Yeah. Don't work harder, guys. Work smarter. Now. Okay. Let's begin. Shade Y union Z on the first one. Where's Y union Z? Everybody happy with that? Bar my bit where I went outside. Okay. Hence shade X intersection Y union Z. So if that's Y union Z, and it has to have stuff in common with X. So I'm going to shade in X now. What region are we talking about here? The green region, isn't it? Yeah. So what am I going to do here then? I'm just going to rub away the other stuff, haven't I? And it's just going to be the green part, isn't it? Okay. Lads, are you all happy with the just the colour way of doing it? Just like shading it sort of in your head. Okay. So, yeah, you get the gist, the green part. Right. Next part. Draw a Venn diagram and showing X intersection Y union X intersection Z. Okay, I'll do X intersection Y first. Where's that? Yeah. Where's Y X intersection Z? And we want both of them. So it's just the yellow region. Finally, which property have you just proved? They're the same answer. Lads, they're the same answer. What happens? Intersection was once here, but it's twice down here. So what does that mean? Intersection is distributive over union. Hooray.